Hello and welcome back. So now in this session we move on with our Numpy arrays and we learn how to select and manipulate single elements and also how to make slices and subsets of Numpy arrays. And actually the mechanics here are the same as with lists and other data containers we can iterate over. However, there are some hidden differences to lists that can cause severe problems if you are not aware of these. So first of all, let's import numpy as np. Then we create a numpy range from 1 till 10 including. And zero indexing, which we learned with lists, also applies to numpy arrays. So we can select the first element with the index position 0. Consequently, we get the second element at the index position 1. And the last element at the index position -1. We can also apply the enumerate function to a numpy array and create tuples of index value pairs, and then we can store these tuples into a list. So we can see here at index position 0 we have 1, at index position 1 we have 2, and so on, and at index position 9 we have the element 10. There are no surprises with slicing, so we can slice from the index position 2 until index position 6, and 2 is including and 6 is excluding. Also, we can get all elements by just having nothing on both sides of the colon. This is the whole array here. And we can also slice from the first element including until the index position 5 excluding. So nothing colon 5 gives us 1, 2, 3, 4, 5. So the first 5 elements. Also we can slice from the 6th index position until the very last element including. And what we can also do, we can select every second element starting from the very first element by having a double colon. So starting from the very first element, we have every second element, 1, 3, 5, 7, and 9. And also we can select every third element, and also every third element beginning from the element at index position 2. Same as lists, numpy arrays are also mutable, so we can change elements. And first of all we select an element, so here the element at index position 0, and then we assign the new value 100. Let's see what we get. So we get our array A with 100 at index position 0. And we can also change, for example, the very last element and assign the value 101. It's no problem. And now here it comes a difference to lists. So with lists, we couldn't assign a single value like 50 to many elements. This is called broadcasting, and this was not possible with lists, but we can do this with numpy arrays. So let's see what we get. So we assigned to the element at index position 2, 3, and 4 the value 50. And we can also, like with lists, assign multiple new values to multiple elements. So to say to the element at index position 2, 3, and 4 the values 50, 51, and 52. So assigning multiple new values to multiple elements works with numpy arrays and lists, but here broadcasting one value to multiple elements only works with numpy arrays. So that's a small difference here to lists. Alright, so let's recreate our numpy array A from 1 till 10. And then we make a slice or a subset of A and call it B. So we slice A from index position 2 till 8 excluding. And we assign the variable B. And now we want to change one element. So for example here the first element at index position 0 to 100. We can do that. But we have to be aware that also the same element has changed in our original ND array A. So here this is our original ND array A, and we sliced B is equal to the slice 3, 4, 5, 6, 7, 8. And we changed the first element 3. And this was also changed in our original numpy array A here. So we have also 100 here. And to show you the difference to lists, let's create a list also from 1 till 10 and call it L. and then we make a subset of or a slice of our list and call it m. And if we change the first element of m to 100 and have a look at our original list L, so there's no impact on L. So actually when we sliced here our original list L, we created, a copy of L. So in the end, we had two objects, so the sliced object M and the original object L, and if we change M, so there's no impact on L, and that's a different behavior to our Numpy arrays. With Numpy's array here, when we make a slice of A, we do not create a copy. So B is not referencing to a sliced copy of A, but it's referencing to A itself and only a slice of A. So in this behavior can be a severe pitfall or problem. So let's assume you have a large data set and you stored the large data set in array A, and you make a subset of A to perform some operations on the subset, but your intention is not to change A. You get a problem because A changes as well. And if the data set is large enough, in some cases, you even do not recognize that your original data set has changed also. So if your intention is that you do not want to change your original data set A, so let's recreate it again, you have to make a copy. So if you slice A, you have to make a copy of it by the method copy. So now B is a copy of the slice of A. And then if we change B, so we changed the first element, so A did not change. So that's important. Alright, so we are finished with this session, and in the next session we learn about the shape of ND arrays and how to create multiple dimensions. See you in the next session. Bye.